This is Project 1, video number 1, the video in which I show you how to do the pencil and paper part of the solution for the project. We're told we've got two objects of mass 1 and mass 2. They're sliding forward along one and the same track. Object 2 is behind object 1. We're given the initial velocities and the masses. We're supposed to create a MATLAB function that takes the initial velocities and the masses and calculates the final velocities and returns them. So let's get started on the problem. We got object 1 of mass m1, object 2 of mass m2, both moving forward. We'll call the initial velocity of object 2 v2, initial velocity of object 1 v1. This is a before picture, and in the after picture they're both moving forward at different velocities, different from each other and different from what they were originally. And in between they had an elastic collision. So for the case of an elastic collision, both momentum and mechanical energy are conserved. And in fact, the momentum in the before and after picture is the same. Likewise for the kinetic energy, which is total mechanical energy under consideration here. We don't have to worry about the gravitational potential energy because they never change level, never change elevation. So I'll start with the sum of the momenta in the before picture to the right is equal to the sum of the momenta in the after picture to the right. And let's say on m1 plus m2, m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. I think I'll try to fit in the energy over here. The energy in the before picture is equal to the energy in the after picture, and the only energy we have to worry about here is the kinetic energy. So you got 1/2 m1 v1 squared plus 1/2 m2 v2 squared equals 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared. Alright, we saw this kind of problem in the lab, so we'll attack it in a similar manner. I'm going to multiply both sides by 2. That makes all those, I have to multiply both terms on each side by the 2, so 2 times 1/2 is just 1. So I can just cross it out. And I'm going to gather all the terms involving with mass m1 on one side and the other ones on the other side. So I'll have m1 v1 squared minus m1 v1 prime squared just in case that doesn't really look like a plus sign. There. Equals, so I subtracted this from both sides, and then I'll subtract this from both sides, so I'll have m2 v2 prime squared minus m2 v2 squared on the right. Factor out the m's on both sides. So on this side I've got m1 times v1 squared minus v1 prime squared. And that's going to be equal to, factoring out the m2, that expression. And then I've got the difference between two squares on both sides, so I'm going to write that as the difference times the sum. So that makes this m1 times v1 minus v1 prime times v1 plus v1 prime equals m2 times v2 prime minus v2, then times v2 prime plus v2. Now I get to work on this equation. I'm going to do the same thing with the momentum equation. Factor the m, get all the m1s on one side, so m1 v1 minus m1 v1 prime, and all the 2's on the other side. Then factor out the m. I'll make sure this looks like a 1 and a 2 there, so m1 on this side equals m2. Actually, I think I want a little bit more room there, so m1 times v1 minus v1 prime equals m2 times v2 minus v2 prime minus v2. Now I'm going to call this equation 1. And I think the way I'll describe it is to divide this equation by equation 1. So this gives m1 v1. I'll just go ahead and copy it down. So on the left, I'll divide by the left-hand side of this equation. And on the right, I'll divide by the right-hand side of that equation. I'm dividing both sides by the same thing because this is equal to that. And that's a legitimate step in algebra, dividing both sides by the same thing. Alright, I see a lot of stuff cancels there. Well, first off, I got to write it correctly. So that was a 2 right there. I got to copy that down as a 2. Then m1 over m1 is just 1. So we can say that cancels because 1 times anything is that something. And likewise for the ratio of v1 minus v1 prime to itself. Over here, the m2's cancel, and this difference cancels. So I'm left with v1 plus v1 prime equals v2 prime plus v2. So I think I'll solve this. for v2 prime. v1 minus v2 plus v1 prime. And then substitute that into, guess I can substitute it into equation. I think I'm going to change my number in system. I'll call this 1, and that makes this 2. So divide by equation 2 instead of 1. So substitute this into 2. I'm going to number this one equation 3. Alright. What does that give us? We'll get M1. This side doesn't change. Oops. I wanted to substitute it into equation 1. Which I don't think I can see. So I'll copy down 1 first. Oh no, I can remember it. Alright, M1 plus, okay. So we had M1 V1 plus M2 V2 equals M1 V1 prime plus M2, and this is where the substitution comes in. It was V2 prime, and I'm substituting this in for it. V1 minus V2 plus V1 prime. And I'll multiply through by the M2. Minus M2 V2 and then plus M2 V1 prime. Now gather all the terms that have V1 prime in it on the right, but I'm also going to switch sides, so I'll call it on the left. So that's M1 V1 prime plus M2 V1 prime. And then that's equal to, I'm taking everything else over to the left, but I'm actually going to write it on the right. So I've got an M1 V1 original, and then I've got two M2 V2s, because when I add this over to the other side it'll make 2, so plus 2 M2 V2s, and then plus, and oops, minus an M2 V1. So I'd be subtracting this from both sides, adding that to both sides, and so I would have 4 terms over here, except that 2 of them were the same. These 2 combined to give those, and that got subtracted, so I got the minus sign. Okay, that looks good. Factor out the V1 prime, so I got an M1 plus M2 times V1 prime equals m1 v1 plus 2m2 v2 minus m2 v1 all divided by m1 plus m2. No, I don't want to divide yet. Okay, divide in this step. So v1 equals, and that was a prime, by the way, factored out of v1 prime on that side. So v1 prime equals what I just had written. m1 v1 plus 2m2 v2 minus m2 v1 all divided by m1 plus m2. Alright, the units work out. Up top, every term is a mass times the velocity. I divide that by a mass. I'm going to have units of velocity. And it is just the given stuff up there. So I'm going to call that the equation that I need for v1 prime and I'm actually ready to write my code, the code outline. So code outline, let's try it. So it's not quite like on the lab because I don't have to substitute, but you might want to do that. Anyway, so that we have a check. But first, take arguments, the arguments of the function that which the values or variables that the function is given. It's actually values. And m1, m2, v1, v2. Really have to take those. There's a given. Evaluate. Let's say I'll call that one equation 4. So my step 2 is eval equation 4 v1 prime. Then I'll have a value for v1 prime, so I can use that in equation 3 along with known stuff. So evaluate equation 3 for v2 prime, and then set v finals equal v1 prime comma v2 prime. That'll be my two-dimensional output array, and this will be my return variable. Alright, that's all I got to do for the code outline. Now you guys have some values from your lab to check. I don't, so I'm going to see if I can evaluate this by hand. So if you don't have them already, like you guys do in the lab, you guys should just make a table of what the answers are for what input. So in other words, you have a mass 1 and a mass 2, a velocity 1 and a velocity 2 that you determined from the lab, you measured in the lab, and you've got calculated values for V1 prime and V2 prime from the lab. So make a table of those, and that will be what you can use to check to see if your function is working. I'm going to use M1 equals 500 grams, so 0.50 kilograms. M2 equals, so I think I'll say using. So your code is supposed to work for anything, but if I use these values, I should get whatever I calculate it to be. I'll go 1.500 kilograms. I'm just making these values up. And then let V1, that one was in the lead, I'll call that 0.300 meters per second. And V2, I'll let that be, that was the one that was catching up with that, I'll call that 0.500 meters per second. And then what we can do is evaluate these expressions by hand. And I'm going to go ahead and do that without showing the work. And I'll just say should get I use the calculator to get these. You can write this exactly the same way. Using the values that you had in the lab, you should get, and then you just get to copy down the values from the lab. I'm going to evaluate these by hand, and as long as I don't make a mistake with the calculator, that's I should be getting the same results with the program. And before I do that, I want to remind you, you should have lab values here, not mine. Not these values. Alright, but when I evaluate it by hand, I get V1 prime equals 0.600 meters per second, and V2 prime is equal to 0.400 meters per second. And let's see, this makes sense. The one in the lead got sped up. The trailing one slowed down. The trailing one just slowed down by 0.1 meters per second, whereas the leading one sped up by 0.3 meters per second, which makes sense because the leading one was of lower mass. So it passes my common sense checks, and I think I'm ready to go ahead and program this up and use this as a check. So I'll call this the end of Project 1 Video 1.